Have you ever hit a wall in math class, trying to find the square root of a negative number? It just feels impossible, doesn't it? Well, today we're going to break through that wall by diving into complex numbers. And listen, they're not complex as in they're difficult. They're complex because they open up this whole new dimension of what math can do. Let's get right into it. So here's our game plan for today. We're going to start with the one problem that kicked this whole thing off, then we'll get a handle on what complex numbers actually are, and then we'll walk step by step through adding, subtracting, multiplying, and even dividing them. By the end of this, you're going to have a complete toolkit for handling these awesome numbers. Okay, so where does this whole journey begin? Well, it starts with a question that for centuries just stumped mathematicians. It was a problem that had no answer. At least not in the world of the numbers they were used to. I mean, really think about it for a second. A positive number times itself is positive, and a negative number times itself is also positive. So in our normal number system, there's just no number out there that you can multiply by itself to get a -1. It's an impossible problem. Or is it? Well, when you have an impossible problem in math, what do? You invent a new solution. And that's exactly what happened. Mathematicians came up with this brand new number, this elegant little I, and they gave it one single job, to be the square root of -1. This little guy, the imaginary unit, is literally the key that unlocks everything else. And this is where I becomes so incredibly useful. All of a sudden, we can handle the square root of any negative number. The process is always the same. You just pull out the square root of -1, which we now call I, and then simplify whatever's left. So if you look at that first example, the square root of -27 just becomes 3i times the square root of 3. It's a clean, simple trick that works every time. Okay, so we know what I is. But what about something like I squared, or I to the 21st power? You'd think it would just get more and more complicated, right? Well, actually, the answer is kind of beautiful and surprisingly simple. It turns out there's this incredible pattern. Check out the cycle on the right. I to the first power is just I. We already know I squared is -1. Then I cubed is -I. And I to the fourth power brings us right back to +1. And then the whole thing just starts over. It's a perfect, predictable, 4-step loop that goes on forever. And because of that repeating cycle, we have this awesome shortcut. To simplify any power of I, all you have to do is divide the exponent by 4 and just look at the remainder. If the remainder is 1, the answer is I. If the remainder is 2, the answer is -1, and so on. As you can see from these examples, it's a little trick that makes huge problems incredibly simple. All right, now that we understand our main building block, I, let's see what we can build with it. Because I isn't just some weird standalone idea. It's the foundation for a whole new type of number. So this is what they look like. Every single complex number can be written in this standard form, A plus BI. The A part is what we call the real part. That's just a normal number you already know. And the B part is the imaginary part. Everything from the number 5 to something like 3 minus 2i fits right into this structure. Okay, so we know what they look like. Now let's start actually doing some math with them. And here's the good news. If you've done any basic algebra, this is going to feel very familiar. The number one rule for adding and subtracting is super simple. Like goes with like. You just combine the real parts together, and then you combine the imaginary parts together. That's really it. You pretty much treat the I just like you would treat an X in an algebra problem. Let's see how this works. For addition, we take the 4 and the -12 to get -8, and then we take the -11i and the 6i to get -5i. Simple. Now for subtraction, there's just one little thing to watch out for. Remember to distribute that negative sign first. Once you do that, it's the exact same process. Real with real and imaginary with imaginary. All right, time to level up to multiplication. Now, this is also going to feel a lot like algebra, but there is one absolutely crucial extra step that we always have to remember. So, the method here is FOIL, just like you'd use for binomials. First, outer, inner, last. But here's the key difference. See in the example where we end up with that -4i squared? You can't stop there. You absolutely must replace I squared with -1. That one little substitution is the most important step, and it's what lets you simplify the whole thing down into its final form. And now it's time for the final boss of complex number operations, division. It definitely looks intimidating at first, but once you learn about its secret weapon, you'll see it's just a clear, step-by-step process. So here's the main issue we're trying to solve. In math, it's just considered bad form to leave a radical in the denominator of a fraction. And I is technically a radical, right? It's the square root of -1. So the big question is, how do we get that I out of the bottom? We do it by using this amazing tool called the complex conjugate. All you do is you take the complex number that's in the denominator and you just flip the sign in the middle. Why? Because, and this is the cool part, when you multiply any complex number by its conjugate, the imaginary I terms always cancel each other out, leaving you with just a plain real number. It's the perfect tool for the job. So this gives us a crystal clear 4-step plan. First, set up your fraction. Second, figure out the conjugate of the bottom number. Third, and this is key, you multiply both the top and the bottom by that conjugate. And finally, you just simplify the whole thing down. Let's watch it work. Okay, let's walk through this one together. So our denominator is 6 plus 2i. That means its conjugate has to be 6 minus 2i. Now we multiply the top and the bottom by that conjugate. On the top, we just FOIL it all out like we did before. But look at the denominator. Watch what happens. The middle I terms cancel out perfectly, and we're just left with 40, a nice, clean, real number. From there, it's just a matter of simplifying the fraction to get our final answer.
Wow. So we've gone from an impossible problem all the way through every basic operation. Let's just take a second to recap the essential tools you've just added to your math toolkit.
Really, it all boils down to these 3 big ideas. First, remember that the powers of I just repeat in a simple 4-step cycle. Second, when you're multiplying, never forget to replace I squared with -1. And third, when you're dividing, the complex conjugate is your best friend. It'll always clear out that denominator for you. If you can master these 3 things, you've totally got the basics of complex numbers down. I just love this quote from the mathematician Leibniz. He calls it an amphibian between being and not being. It perfectly captures how strange and beautiful these numbers are. This idea that they're a bridge between what we thought was real and what we decided was impossible. They're not just a math trick, they're a fundamental expansion of what numbers can even be. And that really leaves us with a final question. History has shown us that every time we expand what we mean by the word number, going from whole numbers to fractions, to negative numbers, and now to complex numbers, we unlock the ability to solve a whole new universe of problems. So it really makes you wonder, what's the next impossible problem, and what new kind of number are we just waiting to discover to solve it? Thanks for joining this explainer.